Aircraft carriers operate like floating air bases, but they face one major limitation: range. Carrier-based fighters must launch, travel to their mission area, and return to the ship before running out of fuel. Every mile of range determines how far a carrier strike group can project power. The MQ-25 Stingray exists to change that equation. Built by Boeing, the MQ-25 is an unmanned aerial refueling aircraft designed to extend the operational range of naval fighter jets. Instead of carrying weapons or surveillance equipment, its primary mission is simple: deliver fuel in the air. By refueling aircraft mid-flight, fighters like the F-35C and F-18 Super Hornet can travel significantly farther before returning to the carrier. But the engineering challenge isn't just building a drone, it's building a drone that can operate from an aircraft carrier. Carrier operations are among the most demanding environments in aviation. The runway is short, constantly moving, and surrounded by ocean. Aircraft must launch using catapults and land using arresting cables. Human pilots train for years to master these operations. The MQ-25 must perform them autonomously. During launch, the aircraft connects to the carrier's catapult system. Steam or electromagnetic catapults accelerate the aircraft from 0 to flight speed in just a few seconds. The drone must maintain structural integrity under sudden acceleration forces. Navigation begins immediately after launch. Autonomous flight systems guide the aircraft toward its refueling location while maintaining communication with the carrier and nearby aircraft. Precision navigation relies on satellite positioning systems, onboard sensors, and secure data links. Communication reliability becomes critical. If the aircraft loses its connection to command systems, it must continue operating safely using onboard autonomy. Redundant navigation and flight control systems ensure the aircraft can return to the carrier even if communications are disrupted. Refueling itself requires precision. The MQ-25 deploys a hose and drogue system behind the aircraft. Fighter jets approach from behind and insert a probe into the drogue to receive fuel. Both aircraft must maintain extremely stable relative positions during the transfer. Turbulence, wind, and small control inputs can disrupt alignment. Automated flight controls help stabilize the tanker aircraft while pilots carefully maneuver their fighters. Then comes recovery. Landing on a carrier is one of the most demanding maneuvers in aviation. Aircraft must approach the deck at precise speed and angle, aiming to catch one of several arresting cables stretched across the runway. When the hook catches a cable, the aircraft stops in just a few hundred feet. The MQ-25 must execute this maneuver without a pilot on board. Advanced flight control systems and sensors guide the drone during final approach. The aircraft monitors deck movement, wind conditions, and glide slope to maintain the correct landing profile. Even small errors could result in a missed cable or unsafe landing. Another constraint is fuel capacity. The MQ-25 must carry enough fuel to meaningfully extend fighter range while still reserving fuel for its own return to the carrier. Designing that balance requires careful mission planning. The aircraft also must remain compact enough to operate efficiently on crowded carrier decks, where space is limited and aircraft movement is tightly coordinated. Despite these constraints, the MQ-25 represents a major shift in naval aviation. Traditionally, fighter jets sometimes had to carry external fuel tanks or sacrifice weapon capacity to support longer missions. Now, an autonomous aircraft can perform the refueling role instead. That allows combat aircraft to focus on their primary missions. The Stingray may look simple compared to stealth fighters or hypersonic weapons, but its strategic impact is significant. Extending range increases the distance a carrier strike group can operate from potential threats, and distance increases survivability. The MQ-25 demonstrates how autonomy is gradually entering one of the most complex environments in aviation. Not by replacing pilots entirely, but by handling support roles that expand what human pilots can accomplish.